About your talk.
Thank you very much. I don't need that. I've got this on. I can do that.
I'll switch off. Cheers all.
Good morning, everybody. I'm going to start with the serious bit first, and then I'll get rid of that very quickly. So I firstly want to thank the organisers because it's great to be back at a conference in person. I was having friends from overseas saying it had been years since they'd seen firstly a conference and secondly a conference with no mask. So it's fantastic to be here. I do want to acknowledge the traditional owners of the land on which we're meeting today, the Wujak people, and I pay my acknowledgement to their elders past, present and future. I'm going to stop with the serious bits there and I'm going to start with the fun bits. I also want to pay my respects to the traditional owners of the network here, and when I say owners I mean owned, and that would be the Uckans of Cameron Hall. Any Uckans in the room? 1, 2, 3. There's a few around. So the UCC predates the Department of Computer Science here by a number of years, and in a time when identity checks weren't as strict as they are today, they enrolled one of their computers in a degree of computer science. And the paperwork was done by volunteers. By paperwork I mean exams, was done by volunteers within the organisation, and so one of the servers inside the UCC obtained a degree of computer science here at UWA. The legend became myth, and over time this identity, a computer called Murphy, obtained a doctorate just by name change effectively, and is the official contact address for the computer science hackers here on the university. So I'm going to give you a little bit of a run back through some of the web stuff which has been happening, because I've traditionally been more on the blue team of things, not so much a destroyer but a defender, and it is an interesting space which is changing fairly rapidly. But first I'll tell you a little bit more about why I'm here and why I'm talking, take you through some certificate authority changes, and obviously there's a lot going in that space. We touched on the history generally of cryptography, but we're going to talk about some of the stuff which has been happening that is real world today, and stuff which is stuff you can change which doesn't cost any money, to try and help protect what you're doing. So firstly, a bit of PII. I've obfuscated a few bits and pieces because nobody goes to a hacker conference and hands out everything. So please take my mother's maiden name and put that into your user agent string, and hilarity will ensue. I'm actually surprised that the organisers managed to receive my presentation and it didn't get flagged up, so that was that's great. So no, yes, and my dog, little drop tables. So I've been a volunteer in the tech space for some time. That photo was January 2003 when we ran Linux.conf.au here at the university with about 700 people, and we brought Linus Torvalds to Perth way back. I've been one of the Debian developers now for 21 odd years, and that was actually triggered by Toivo Podest, one of the long-term network administrators here at UWA, who was kind enough to set up a Debian mirror back in the 1990s, which was the first major distribution that we had access to here at UWA. I managed to convince Nick down the front here and others to bring LCA back to Perth in 2014, and I served for a while as plug president, and it was a fun time putting Linus in a penguin suit on a 35-degree day. His little girls now have just finished university and are all grown up. So other stuff I've been doing. So I worked for a while for Hartley Poynton, JDV, in their share trading piece. I was the web guy for that. So the only thing that stood between all of the share trading that most of the banks were doing and security was me. I went to Europe for a while. I worked for a division of Canon Europe called Fatango, which was a little Perl shop. Perl is a language you don't hear much of these days. But it did some interesting stuff. We used to have a copy of everybody's photos if you bought a Canon camera in Europe. It was kind of a precursor to Flickr. But we were pretty inventive, and we came up with a concept for function execution as a service in 2005. We started it. 2006 it was launched. And if you look at the serverless history on Wikipedia, that is where basically function as a service started. I moved on to an advertising company, came back to Perth in 2010 with the little O when he was 6 months old, and took a job with a cloud startup company out of Seattle, and did 3 years working for AWS, opening the office here in Perth. Which was a fun ride, very interesting. I got to be the security solution architect for all of Australia and New Zealand, which meant I got to walk inside various data centres around the place morning and write white papers and then walk into the vaults of various banks and tell them about how you'd connect up to the cloud. These days I work for part of the Deco group, Modus, along with a bunch of my colleagues. We look after various agencies and enterprises around town and across Australia. But going way back, I studied here doing a computer science degree, computer science and French, oddly enough, and that will come up in a second. I was an Aachen myself. In fact, I think that was my wheel photo, which is the administrative group for the UCC, back in a long time ago. And my first paid web job was in 1995. And it was that web page there, which was written in French. Yeah? That was one of the things about being the weird guy who came from computer science to the arts faculty and then back again of, you know something about this, I've written up this thesis about French African authors, can we get this online? That screenshot taken last week still renders after 24 years? Yeah. Now, some of you may remember there was a period where there was this technology called Flash. And there were some comments made last week that there was this period of the early 2000s where a large number of news sources that were delivered via Flash are no longer available for archive, particularly around the September 11 attacks. So it's a testament to the vision that Tim Berners-Lee had, Sir Tim, or Timble, of having documents available to be rendered, and the fact that we can still render these things when we have the content. Obviously, the way we get the content has changed subtly over the years. Anyway, I moved on to work for this organisation. I had a job title once called Webmaster, which was basically they couldn't figure out what else I was doing, or campus-wide Information Systems Officer. And yes, the 1997 annual report of this university, screenshotted last week, still renders. And that was a great project. We were doing some really interesting stuff like making the entire university's faculty handbooks from this cut-down version of SGML with my colleague at the time, James Tauber, who worked on the W3C board, and they came up with this new little standard, a cut-down version of SGML called XML, which is seen its time come and go, I think, but still there. Anyway, that's who I am. Anyone got any heckles so far? Oh, God.
Yes, how old was that picture you put on the second page?
Which one?
Keep going. Keep going.
That one? Oh, God. 2014.
Still has white hair.
It's wisdom, okay?
Where can you get a cloud jacket?
Okay. My colleagues actually insisted that I should do this. Yes. It's all been cloud all along because nobody wants to look after servers. Anyone work in data centers here? Anyone? No? No one works in a data center. Good, you're so lucky. It's like casinos, but without the drinks. Okay, so, blah, 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 blah. Yeah, went through that. So, certificate authorities. Some of you would have been around when this came out. This was a reasonably significant event for the web. And today you look at the things that this version supports. International security, do not go there. Because, 56-bit certificates with 40 bits exposed isn't that strong. And in fact, all of those technologies are pretty much superseded today, though I think people were yesterday talking about MD5. Move on, stronger hashes, please. So the certificate authorities have been changing a lot of stuff in there. Now, there are a bunch of free certificate authorities today, but there's a bunch of historical ones. So if we go back, VeriSign and Thought, they came back from a long time ago, but they're all starting to move towards the ACME protocol. And this is not a Warner Brothers cartoon, ACME. This is the automated certificate mechanism for getting certificates. If you haven't used it, you definitely should. The reason because who goes and buys certificates at the moment? Anyone? No one does. A few people do. If it's a manual process, you're going to hate what's happening in the industry because certificate lifetimes are shortening more and more. And there's been a few things that have been raised over the last couple of years to really bring it down. And we all know, probably, that Let's Encrypt is around a 3-month expiry. And people do think about doing it shorter than that, down to days or weeks. You don't want to be doing that manually. You want to have that automated. And if you can automate it in production, you should probably automate it in non-production as well. Now, all of these certificate authorities that are out there are kind of members of a club, the CA Forum. The CA Browser Forum, they pay a membership for to legitimise the fact that they are a certificate authority. As a club, it's got various rules of membership, and a lot of those are technical, such as after this date, you won't issue a certificate of this length or this algorithm, and you definitely won't issue a Google.com certificate to someone who isn't Google.com, because that'd be your job. And of course, this is done quite transparently. There's a lot of people who watch the recommendations that come out of the Browser CA forum and then go and check various public sources to make sure it's being enforced where possible, or if it's not having the transparency of daylight, calling it out and saying, hey, there's something going on here. And there's a long history of very well-known certificate authorities being caught out for transgressing those rules over time. One interesting piece was certificate transparency. So certificate transparency was introduced a while back now to actually show when a CA issues a certificate. So for example, if I was to issue a certificate of davidstockbridge.com, you'd probably want to know about that, Dave, especially if I'm sitting in the opposite side of the world and you've never heard of me. If you look at your phone or your browser, there's a large number of certificate authorities who are already trusted. And they may all be legitimate businesses. In fact, they should be. But do you choose to trust them? Well, by default, your browser has made an initial selection to say yes, but you may wish to review that list and remove those that you don't intend to visit services of online that use certificates issued by those certificate authorities. So, certificate transparency has changed. There's a log of, in fact, there has to be 2 logs of every certificate issued by every legitimate CA. It's one of those rules of the Browser CA forum. And these days, the actual location of those logs is embedded into the TLS certificate that you get handed, or going through automation, so you can actually go and find that log. Now, there was a security header for a while that indicated that that should be expected, but this is pretty much de rigueur these days. It happens automatically. There's new requirements coming up, and we saw yesterday about RSA certificates. And these days we're starting to move into elliptical curve certificates, which is described as being the bowling ball algorithm of you start at this point, you've got a curve, and if you go in this direction, you bounce around to get to a destination number. That's the trapdoor function, or the one-way function of that algorithm. And bit for bit, it is supposed to be more secure than a traditional RSA certificate. RSA certificates get longer and longer. We spoke yesterday about 2048-bit certificates. I've got some 809 or 80192-bit certificates that are quite long. The longer you get with RSA, it goes much, much slower. And so newer certificate signing algorithms means that this is faster. So that's all very interesting. Moving on to some bits and pieces. One thing you might want to do is be able to tell that list of legitimate certificate authorities that when you as an organisation want to go and buy a certificate, which CAs are you going to authorise to be your CA? And that is the certificate authority authorisation record that you can squirrel away in DNS. It's only ever looked up when a certificate authority is about to issue a certificate in your common name, your DNS name. So it's hardly ever used. You can set this at a 0-second TTL. No one else ever looks it up. And you can specify whether those certificate authorities are allowed to issue explicit name certificates or wildcard certificates or both. You can list as many CAs as you want, and it might even stop you from having sort of shadow IT going out and going and buying a dodgy certificate from the South China Post, who are a legitimate CA, but you might not be choosing to use them. It's surprising. This has been around now for quite some time. January 2013, nearly a decade. And you could probably count on 2 hands the number of organisations in Perth that have actually gone and set this record up and put it in there. I spoke briefly about the certificate algorithms. They are changing, and as a result of that, a certificate chain from the issuing CA is also being upgraded to be based around the elliptical curve algorithms. So ECDSA new routes are being created. Let's Encrypt has just moved to one of these new routes after being on an existing RSA-based route for many years. They've called them names like X1 and X2. Sounds very spooky. Turns out they're calling these certificate names with as short a name as possible. Anyone want to know why? Why are they making the names very short? Because they're transferred over the internet so very much that every byte is sacred. They're literally making the names of the CAs short. So, new certificates. In fact, there's an opt-in at the moment on Let's Encrypt if you would like to be vended through the automation you have in place, an ECDSA-based certificate. Browsers have supported this for several years at this stage. Okay. High-level stuff, TLS changes. Now, everyone in this room has probably heard about TLS. It's what's protecting most of what we do every day, especially as we've managed to digitize pretty much everything in our society. Whole bunch of versions. 4 years ago at this stage, or 3 years ago, was TLS 1.3 coming out. Basically, and I don't know if you can read the red on green, that was a thought this morning about color blindness, but don't use any of the first bunch. They are absolutely bad. In fact, they are so bad that the IETF has a request for comments, and if you've come across RFCs before, by the time you probably see it, it's no longer requesting for comments, it means standard, but don't use anything less than TLS 1.2. And all of those earlier revisions are so bad, and we as an industry have been so lax at removing them that the vendors themselves are removing implementations from their software base to force the fact that these things are turned off. If you're waiting for the next update to disable older versions of TLS, you're probably waiting too long. You could probably go and turn these things off right now. Good logging will show whether or not they're in use. They shouldn't be. If they are, you've got some really outdated software that you've not updated somewhere else. You've probably got a whole host of other issues out there. So, if you're ever looking for compatibility online, there's a website called caniuse.com. And you can put in all kinds of technologies that you want to use in the browser, and it will tell you the support matrix as it looks like over common browsers. And most recent versions have got very good support for that. If you wanted to use TLS 1.0, you are going to get a bad day because all browsers that are out there in common use these days no longer support it. So why leave it enabled? You might have some automation integrations happening which aren't using a traditional browser. Fair enough. You probably should have updated those anyway. I'm going to spill outside of web for a moment, and there was one other great thing that I've seen recently, and that is a nice update to Windows Server. So at the beginning of this month, there was a new version of Windows Server that came out, 2022. And it is the first one where the cryptographic provider on the host, S-Channel DLL, supports TLS 1.3. So I can see that in future being one of those forcing factors of we need to get to that version because we've removed all of the older versions of TLS out of our environment. OpenSSL has TLS 1.3 support since version 1.1.1. I think it was K or L. It's on its 12th update now. Big update last week. OpenSSL 3 was released. Currently going through FIPS validation. Again, all change, upgrade where you can. TLS 1.3 only supports a small number of ciphers. The reason for that is there were a lot of older, weak, bad ciphers that really you shouldn't be using anymore, and including some modes of AES, the Advanced Encryption Standard, previously called RINGL. So AES mode that you most commonly see these days is called GCM. Anyone here heard of GCM? Yeah, anyone tell me what it stands for? Yeah, Gaulois counter mode. This young man here is Évariste de Gaulois, a young French mathematician. Now, I've got a degree in mathematics, you do too, and this is where we're going to claim some credibility because at the age of 20, he got into a duel over a woman. Sadly, he died. So his aim might not have been as good. His last words were, "Don't cry, Alfred," his friend who was with him at the time. I need all of my carriage to be dead at the age of 20. His field of mathematics was so misunderstood. He was denied access into the Académie Française for multiple years, and it wasn't until years after his death that what he was doing with his field was seen as actually being valid and secured. And pretty much every transaction you do nowadays is using his branch of mathematics to secure those transactions. And that is my link to French in this. Très bien. On y va. Browser changes. Now, unless you've been living under a rock, browser versions on the open web have been looking a little bit like this. That green line is versions of Chrome, dominating very much so. I've been a Firefox user for many, many years, kind of declining off to the right-hand side there. But that's not the most interesting piece. It's this one that I find is really interesting. It is the rollout version that is actively in use. And I think that this has been a testament to things like the approach on releases being lots of incremental small releases. Those that think back sort of 15, 20 years ago, a new release of a browser was a potentially world-ending moment of compatibility changes. These days, this is done in a very slow, incremental way. What's also interesting is that mum and pop at home who are doing auto updates probably are running the most recent browser. And your standard operating environment in your organization, which is version locked, is probably not. And some agencies in Western Australia will choose current -1 version to be their SOE and then not touch it for 4 years. And you start sitting there going, well, that bug is fixed for everybody out there, but not us. And so one thing to look at is, well, maybe we should be actually being a little bit more agile in corporate environments for certain critical applications where the security update comes in through good mechanisms to make sure they're getting pushed pretty quickly. So as I said, other things you can look at in can I use? Versions of images have been improved. WebP is looking pretty cool these days as a format, not supported in everything. I was pasting WebP images into Teams the other day, it didn't understand it, but the efficiency that you get on that is huge and fully supported across browsers. One hack that happened a while back was the takedown of an accessibility service online, and it brought my attention around to sub-resource integrity. Sub-resource integrity is the ability for you to say, look, I've got this library or framework, typically JavaScript, could be a font, could be anything, to be honest, and I'm loading it from an external CDN or an external site, something that is from another origin, but I don't want it to change. I want to make sure that you're still running the same version because I've got an external dependency now. Now, prior to this, quite often people would have example framework.js, and whoever was running that CDN was free to update it at any time they wanted to. They could do maintenance on it, new functionality, but also they could be compromised and take down everybody who was leveraging that shared CDN resource. That happened with this accessibility service that was running. There were organisations here in Australia, a lot of public sector in the UK was taken down with it, and cleverly enough, the injection that was put into it was a Bitcoin miner with a throttle to, I think, 50 or 70% of CPU, so that people wouldn't recognise that their browser was just going sluggish for a bit. So you can definitely generate integrity checksums. In fact, you can generate multiple. In this case, it's a SHA-384, and your browser will actually validate that the cross-origin resource that it's just loaded does actually meet that checksum before it loads, executes, or uses it. Important, for example, in fonts. There's been a lot of font vulnerabilities over time. And cross-origin means don't actually add any cookies or any other indications to be able to tell who I am. You can generate those SRI hashes online from that website, and if you are leveraging third-party CDNs, do so. If the resources are all self-contained on your own site, well, it's the same source which is going to be compromised, so there's not a huge amount of advantage in doing so. There's been a lot of security headers added into browsers. Now, this kind of stuff is only really for desktop browsers. If you've got native integrations, then it's not implementing this kind of stuff. My favorite in here, and I know I've got a typo on the next slide, is the strict transport security. This header basically is something you can put on your service and say, hey, if you're happy with my crypto at this stage, just remember for some cache age, a year, that I'm always a crypto site. Don't even try unencrypted HTTP. This is changing over time because browsers slowly are starting to go to HTTPS by default. It's 2021. And I've got a bit on that in a second. So you can enforce this also for your entire domain. That's a big one-way trip. If you're going to say every service under my domain name, including intranet.example.com, is an HTTPS service, you're saying you're going to use HTTPS for everything, which is a good thing, but might catch you out by surprise if your intranet currently has that big not secure warning in the browser Chrome at the moment. You can preload that also. So once you've got the HSTS header on your service, you can tootle along to HSTS preload, register your site in that, and the browser manufacturers go and pick up a database to precede the next version of their browser that you will automatically get via the crossover mechanisms of versions, that it won't even need to make that initial unsecured HTTP request. And of course, most of that initial unsecured HTTP request is a redirect to go up to HTTPS. Don't even bother with that. Interestingly, I was running a poll on LinkedIn the last couple of days asking which organizations have blocked HTTP from their users. So if you go into your corporate environment, can you actually get to neverssl.com. So neverssl.com is an HTTP-only site run by one of my former colleagues at AWS, Cole McCarthy, and it's designed that you've got something that is always going to be an HTTP endpoint to validate. Why you would still have that on your corporate network when most of your users are going to always go up to HTTPS? Why would you start with an untrusted source? Beats me. But of that poll, no one responded that their organization had taken that move to block unencrypted HTTP. I have worked with someone recently to do that in their production environment, and it's a great step forward. Okay, referrer policies. This is one source of information leakage, which I think we were speaking about yesterday, about following RFID chips from medical implants that might actually disclose who the user is or their user ID. This is disclosing the origin or the host name that you were referred to between sources. These days, you don't really need it. A lot of that was used for analytics in the early days of the web. Most of this is done now via Google Analytics and other JavaScript providers. So you can actually turn off the browser doing any referrers. Saves a few bytes, and actually the less information you collect, the better. Permissions policy. Your browser is a pretty powerful beast. Your browser has an accelerometer in it, a GPS. It's possibly hooked up to your NFC payment providers. You can actually disable those features in your browser by setting various feature policies on your content in the headers, which if you've got third-party JavaScript being executed, you can scope it so that third-party JavaScript cannot get the GPS locations for your users, but potentially you can from your own JavaScript. Nice little bit of security protection for your customers. Nobody wants to see the Strava event again of where are all the people. It's been renamed. It was called permissions policy, but about 6 months ago that header got renamed and reformatted ever so slightly. No one's heckling. Anyone?
It's very early.
It's very early. Yeah, but it's very exciting. I mean, this stuff has taken years to get to the point of having a velocity where there are interesting changes that are happening as a result of interesting stuff happening with people. Exploits of, I linked into a third-party site and they started getting the GPS location for the visitors to my service. That's bad. CSPs, content security policies. So this defines where your browser is going to allow to load stuff from. And more interesting things like iframes. Now, iframes have for 15, 20 years been considered bad, but they're still used. If you've got a frame inside a page, what would stop that frame from loading another frame from somewhere else? Or what stops a legitimate browser from being tricked into hosting your banking homepage in a malicious parent frame? So luckily CSP gives you that capability. You can specify what sources are available to be within your descendant frames and where you're allowed your ancestor frames to be. Typically, block everything. This is where extending previous functionality that was there in some various experimental X headers, but you can do this now in CSPs. One of the ones tying into what I was talking about earlier was certificate transparency. This header is actually going away because all of the certificate transparency is now in the certificate. You don't need to go and look up third-party log files, so you can get rid of them. June 2021 it was supposed to become obsolete, so there we go. I've got a few very interesting ones that have just come up as well. Cross-origin embedder policies. So allowing a site to say my assets should be loaded by a specific host. And again, we're looking here at legitimate browsers which are being tricked by third parties remote to them, that the legitimate browser can be used to assist you in your security profile. And these are going to basically make things like pop-ups not share context for the JavaScript engine between the pop-up and the window under it. They'll be in different origins, therefore they shouldn't share context. These things I would definitely recommend. Have a look into them. They've only come around in the last couple of months. And they sit with cross-origin resource sharing headers as well. Okay, but what I think is actually now much more interesting is how the hell do you hear if a tree falls in a wood and no one is there? I.e., you've got people using your service and they get a JavaScript error out on the internet. Traditionally, you would never hear about any of this stuff. But there's another header called the network error logging headers and reporting mechanisms, which can tell a browser if you have any issues with this site, please report to this location, but remember this location for the next year. So even if that person is in a walled garden of an airport, if we remember what those were, then they might get denied access to your service, and when they next come onto the network and do have access, they'll trundle a report off to you saying, at this time, I was on this address, I couldn't get to you, or I had a certificate failure, or I had all kinds of network failures on those classifications of reports. Really interesting stuff that you wouldn't have seen. And there are services out there that you can just subscribe to have them receive, show and log your errors that are coming from your clients. And the nice thing is that by doing that, you can find out the bad news about, hey, we've got broken images, our JavaScript doesn't work in this specific browser, faster than waiting for your users to phone up your help desk, get through level 1 to level 2, to a developer, to a release cycle. As M said once in one of the Bond films, unlike the Americans, we prefer not to get our bad news on CNN. Get your own bad news first. Those reports are delivered as JSON, something like that, so you can see whether it was a content security policy that was transgressed or anything else in there. Certificate pinning is one that I'm going to do on. I see a few laughs. Do not do this. This is the shoot yourself in the foot, oh my god, I needed to change my certificate, but I've told everyone I'm not changing it for a year. I would call this the career limiting move. So yes, just don't. And that's actually a good thing. These things have come around, been experimented with in production, and then deemed, you know what, let's not. And it's that level of experimentation which has really moved things forward a hell of a lot. Firefox and Chrome no longer support FTP in the browser. They never supported FTPS, so don't. More recent versions of Chrome using HTTPS by default, except for special addresses like localhost and others like that. It's the start. Nick, yes?
If they supported magnet links, they wouldn't need an SRI hash.
If they supported magnet links, they wouldn't use an SRI hash, very possibly. Yes. Other changes. So as of version 91 in Firefox, only in private browsing mode, anything you click or enter will be upgraded to HTTPS. So this is obviously very fine-grained testing before it becomes a blanket rollout of HTTPS everywhere. Mixed content is blocked as of the end of last month in Chrome. One of my favorites, triple des is removed as a cipher. Yay! For anyone who doesn't know, des was okay, triple des was stronger. Double des in the middle there was weaker than both of single des and triple des. Just don't. Another change that some of you may remember was extended validation. Yeah? You could get an even better certificate with a guarantee, a warranty of some sort, and instead of showing a host name, it would show your registered company name. So, for example, Stripe Inc. Has anyone here heard of Stripe? Yeah, what do? Oh, no, I'm talking about Stripe Inc. of Wichita, who are in a totally different environment, who could actually make a browser come up with Stripe Inc., which looks exactly like the Stripe you're all thinking, this is terrible. And so this shakedown, this approach of running a business of going, for extra money, we will display something different, is basically dead. If you're currently buying extended validation certificates from a CA, consider not, because it's just not worth it. Protocol changes in the beginning. In fact, HTTP 0.9 in the very beginning, but HTTP 1.0, open a connection to a server across the network, request something, get that object, close the connection. Oh, look at me, I need to go and get something else. Off we go again, open a connection, request something, get it. Oh, I need something else. Browsers got around that with having multiple streams or threads in parallel doing that. We moved to HTTP 1.1 where we could say, get a connection, open, request something, but hold the phone. I might ask for something else. Yes, I want something else. Trying to optimize the network approach of this. That was 1997, 24 years ago. In 2015, that's a long time between drinks, HTTP 2 moved this from being a plain text to a binary-based protocol, and also streaming parallel threads of transfer for the objects being requested. So you could open a connection and say, I want 1, 2, 3, 4, 5. Whenever you're ready, just send them to me. Little bit of 1, little bit of 3, little bit of 2, little bit of 4, 5, 1, finish 3, finish 2, and all of these things would stream down as quickly as possible. Very efficient on the network. But it did actually start to introduce things like, if I lose a packet on the internet, that stream, although there are multiple threads within that one connection, might then have to retransmit a whole bunch of stuff. And so what we're seeing now is a much bigger change, and this is with HTTP 3. And I'm thrilled to see things like Cloudflare already supporting that. In fact, the BSides website, if you've gone to it, is coming to you over HTTP 3 if your browser is up to date, and you've got access to send outbound UDP traffic. Why UDP? Because it's no longer over TCP 443. Yes, HTTP 3 is really going to confuse your network administration team. And it's going to silently downgrade back to HTTP 2 for the next while. But it's out there, it's fully supported in all browsers, and it's very efficient on the network. Of course, the process of service discovery, there's no dedicated port for HTTP 3. So your browser goes to an initial HTTP 2 connection, sees that header, and goes, okay, the maximum age, MA, to remember this for is a day. I'll just go back and use the same endpoint over UDP to request all of those resources you were after. I think I'm nearly on time. Was that an interesting journey through that? So I've got a few other resources that you can go and use. These are things that are possibly well known. Securityheaders.com, run by Scott Helm out of the UK. Great site, he maintains it really well. Throw any URL into it and he'll give you, after a single hit, these are the headers you've got, these are the ones you're missing, and it's a rating A through F. I'm loving the gamification of security because it makes it really easy for people to go and consume it and incrementally fix things to get a better rating. SSL Labs, Ivan Ristic originally, who's now moved on to Hardenize.com and expanded that out. Hardenize is really good. It goes beyond web security, also looks at things like your TLS for your mail system. You know, yeah, we're all TLS 1.3 on the website. Yeah, TLS 1.0 on SMTP. There's lots of places to go and look at this kind of stuff. Observatory.mozilla.com, the nice thing there is it keeps a history of your scores, so you can see improvements and degradations over time. And of course, for private endpoints, you can use Google Lighthouse, which you've already got in Chrome on your desktop, or testssl.sh, which is a shell script you can download and hit private endpoints for to give you that same kind of visibility of what that profile looks like. Bunch of people you might want to have a look at on Twitter, some really interesting people. One interesting thing I've got up there, and I'll go back to my Ucken days, we registered the domain rcpt.to the week that the .to domain opened, and .to is Tonga. The running joke was as we were wiresharking SMTP, we could see receipt to James at receipt to. It's not hugely funny now, but we thought it was really funny back in the day. And as a result, the Tongan cert now follows me. So that's interesting. But in summary, everything in the technology space that we're looking at, in fact, everything that we deal with is a sunrise and a sunset. New stuff is coming up, old stuff is going away. But don't wait until the sunset to turn stuff off, because it's likely already a poor security choice, and waiting for the vendor to finally remove it is probably way too late. It is a saving function, but you can be much better than that. HTML and IP has stood the test of time. Open source, RFCs and the W3C recommendations for the win. Flash, not so much. And that is the end. Any questions? Yes! Hey, thank you. Thank you. Very kind. Yes, please.
What's the motivation from the registrars for all the CAs that are giving really, really short certs? You mentioned that going down in a day or a week.
One of the primary motivations for shorter lifetimes is once you issue a certificate, it can be out there for a really long time. And if you discover a flaw in a signing algorithm, it might take a long time for the fix for that to be fully deployed in the network. Luckily, RSA has stood the test of time as far as we can tell. There may be quantum computers with large numbers of qubits, which we don't find out about yet, which might not be there, but if they are disclosed, then what's going to be better, changing over within a 3-month period or a 3-year period for the planet? Yeah. That's probably the biggest one. Yeah, good question, thank you. Beside you.
You mentioned
So possibly short lifetimes in that span might be okay.
Yeah, from a user privacy perspective, wanting to ensure that TLS intercept isn't happening, what's the impact on some of the newer protocols? Like, will organizations still be able to do TLS intercept? Will that become more difficult?
So the question I'll just repeat for the stream is TLS intercept and cert pinning. I think one of the key things for TLS intercept is the client base which is being intercepted. In the corporate environment is you're using a corporate device and you've already been rumbled. The internal CA certificate has been pre-populated into your trust store. There's nothing you can do at that stage. You're already compromised. What becomes interesting is the BYOD environment. Do you take the company certificate and subscribe to trusting what the company thinks is Combank or Westpac when you're going through their network? Or do you just tether to your own and not use their bandwidth? Yeah, it's an interesting piece. I see the advantages for doing intercept to be able to scan stuff, but I think there's a lot of things that we need to fix up in corporate networks, one of which is, I mean, anyone here had a phishing email sent to them? Yeah? So there is a large number of phishing links that are sent out where when you click the link, which protocol are you using? For some of them HTTPS, yeah, but there's still a large number that is HTTP. So why support that still? That's a untick that box. But for HTTPS, yeah, that's when you would want to do it. Or domain reputation. You've still got things like DNS lookups happening from clients. So what's the reputation of the host that you're looking up? And does your DNS support actually going, you know what, NX domain for that. I don't want you going to geocities.com because it's got no right usage these days in that context. SNI, for those that know about server name indication at the beginning of TLS, that is being moved to being encrypted SNI because that will also rumble where users are trying to look at. So there's a lot of privacy concerns going both ways, especially in corporate is one, but citizens in oppressed regimes is another one. You know, that was the Arab Spring uprising of 10 years ago or so. And as I spoke about my conference, I'll just call out Dr. David Glantz as well, who was one of our speakers in 2003. Thank you very much. Anyone else? Was there anyone else here at LCA? Yeah, why not shame everybody? In for a penny, in for a pound. Anyone else here who was at LCA 2003 here in Perth? 1, 2, no? Ah, you missed a good conference, it was good. Anyway, any other questions? Yes?
If it's encrypting the SNI now, I mean, in the old days you used to have to, on a multi-homed or a box running multiple sites, you'd have to run it on different IPs or different ports. You're not going to get back into that situation?
No, you shouldn't do. So the question was about encrypted SNI and being able to choose the correct TLS certificate on a host and not needing one unique certificate per host and port combination. That was a terrible situation, of course, made worse by the fact we've got so much IPv4 address space around, haven't we? Oh. By the way, enable IPv6 for everything, please. It's well past time. No, because the other end will be able to decrypt the SNI that you were after to still make that choice. So there is a pre-conversation to actually share a key on that. Thank you for the question. I'm probably over time, aren't I?
You're getting close. There's a heap of questions
Ooh.
in the Discord chat.
Do ask. No.
Most of them said it's a 3-hour bar chat, so I reckon if you jump into Discord, there's a heap
Bar.
of stuff to keep on going. So
Sounds good.
awesome.
Lovely. Thank you, everybody. Thank you, guys. Thank you.
The prestigious challenge.
Oh,
Thanks a lot, guys.
Thank
Really
you.
Getting heaps